The project centers around biometric authentication, which involves recognizing the individual by their distinct physical or behavior traits. The particular emphasis is on ECG authentication, a method that employs real-time user body signals for identification. By utilizing the machine learning methods, a verification model is created to identify the users based on their live ECG data. The project introduced a framework that guides the proper implementation and customization of machine learning technique for ECG-based biometric authentication system. This framework proves beneficial for researchers and developers involved in designing such mechanisms, as it assists in defining the dataset requirements and acquiring the high-quality training data. The project aim is to suggest a framework that utilizes the machine learning technique to build the biometric authentication schemes based on the ECG data. This framework is intended to assist the investigators and developers working on ECG-based authentication system in determining the necessary dataset boundaries and obtaining the high-quality training data. The project strives to provide the guidance to researchers in setting up appropriate machine learning configurations and preparing the required training dataset, including 3 specific user case scenarios. Additionally, the project introduced a publicly available MATLAB toolbox that incorporates the proposed methods, matrices, and sample data. This toolbox serves as resource for further investigation. These are the basic requirements that are needed to build this project. Hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDEL with version of 3.7. These are the modules that are designed to implement this project. The first module is Upload ECG Dataset. In this module, users can upload their ECG dataset to the application. This module allows the user to import the dataset, which typically consists of ECG recording from various individuals. And the second module is Dataset Pre-processing, Fourier and Flipping. This module focuses on pre-processing the ECG dataset. It involves handling the missing values in the dataset and applying the flipping and Fourier transform algorithm to extract the relevant features from the ECG signal. The flipping process helps to normalize the orientation of ECG waveform, while the Fourier transform identify the important frequency components. And the third module is Train SVM algorithm. This module trains the algorithm using the pre-processed ECG dataset. SVM is a supervised machine learning algorithm that learns to classify the data points into different categories. After training, the module calculates the metrics such as accuracy, mean squared error, and mean absolute error on a separate test dataset to evaluate the performance of the SVM model. And the fourth module is Train Decision Tree Algorithm. This module focuses on training the decision tree algorithm with the pre-processed ECG dataset. Decision tree is a supervised machine learning algorithm that creates a tree-like model for making the decisions based on the feature values. Similar to the SVM module, it evaluates the trained model's performance by calculating the metrics such as accuracy, mean square error, and mean absolute error on the test dataset. And the fifth module is Train ANN algorithm. This module trains an artificial neural network algorithm using the pre-processed ECG dataset. ANN is a deep learning model inspired by the structure and functionality of the human brain. The module configures the ANN architecture, trains the model using the dataset, and calculates the accuracy, mean square error, and mean absolute error on the test dataset. The sixth module is Train CNN algorithm. This module focuses on training a convolutional neural network algorithm with the pre-processed ECG dataset. CNN is a deep learning model specifically designed to analyze the visual data using such as images or signals. Seventh module is Train Hybrid CNN algorithm. This module trains a hybrid CNN algorithm, which is a combination of CNN and another type of neural network or machine learning algorithm. This specifies of this hybrid model is to involves incorporating the additional layers or components to improve the CNN performance on the ECG dataset. And the eighth module is upload the ECG test data and authenticate the user. This module allows the user to upload the test ECG data for authenticating purpose. The machine learning algorithm trained in various previous modules will process the test data to identify the user's ID or perform user verification based on the trained models. And the final module is all algorithms comparison graph. This module generates a comparison graph that plots the accuracy of all trained algorithms on the ECG dataset. This visual representation helps in assessing and comparing the performance of different algorithms for ECG based authentication. The execution of the project. To execute the project, first we need to open the code folder. This folder consisting of different files. ECG dataset. Here it is a dataset consisting of different persons' ECG data. And the test ECG. Here it is also the data which is used for testing the model. And the ECG auth and the test are the code files. ECG auth is the main Python code file. And this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this we are interacting with the program. First we need to upload the ECG dataset. Using this button, we are going to import the dataset from the corresponding folder. Here I am selecting the ECG dataset from this folder and click on select folder button. Here we got a screen like this. Dataset is loaded. And then click on data pre-processing Fourier and flipping button. Here it gets the dataset pre-processing completed, and here we can get an cleaning of dataset, and consisting of total persons in the dataset is of 20, and each person ECG contains of total features is 5000. And now click on train SVM algorithm button. Here the SVM algorithm is trained by this pre-processed dataset, and it gives an accuracy of 50% with mean absolute error of 14.9 and mean squared error with 452.3. And now click on train decision tree algorithm button. Here the decision tree is trained with the pre-processed dataset and gets an accuracy of 60%, mean absolute error of 11.8 and mean square error of 354.6. And then click on train ANN algorithm button. Here the ANN algorithm is trained by the pre-processed dataset, and ANN algorithm gives an accuracy of 70% and mean absolute error of 8.6 and mean square error is of 257.8. And then click on train CNN algorithm button. Here, the CNN algorithm is trained with the pre-processed dataset, and it gives an accuracy of 90%, mean absolute error of 2.9 and mean square error of 84.1. And now click on Hybrid CNN algorithm button. Here, this hybrid CNN algorithm is get trained by the pre-processed dataset and gets an accuracy of 95% and mean absolute error of 75%, mean square error of 11.25%. And then click on Upload ECG test data and authenticate user button. Here, upload any one of the test file. I am selecting the test data 2 file and click on open button. Here it is authenticated and belongs to that of person ID number 9. In this way we can authenticate the person by using the electrocardiogram. And click on all algorithms comparison graph. Here we get a graph where x-axis represents the algorithms we used in this project and the y-axis represents the values assigned to each algorithm in this project, and then close this graph. Finally, the project concludes that as new ECG detection device become portable, lightweight, embeddable with smartphones and wearable devices, and connectable with remote servers through the wireless technologies in the near future, ECG-based biometric authentication will be deployed on massive application systems all over the world. To get the high accuracy on user authentication, machine learning techniques are generally adopted to build a more robust evaluation model for ECG-based biometric authentication. The proposed framework in this project describes the general data processing flow of a machine learning based ECG authentication mechanism along with the various function features to help the researchers easily design and evaluate a machine learning based ECG user authentication scheme.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.